Lesson 7, Calculating Forces from Vectors. So far we've been looking at forces, and we see that force arrows show us two things about forces. They show us the direction of travel, and they show us the strength of the force, the magnitude of the force. We've been doing that since year 8. So that means that because it is a number that has both direction and magnitude, it means they are a vector. Now, why do we need to know that? Well, so far in our science education with you guys, we've been doing forces in, that's supposed to be a person, in one direction, in one dimension. So, for example, tug of war. Got a tug of war here, two people. And we're saying, right, Bob pulls this way with 200 newtons, and Jim pulls this way with 350 newtons. What is the resultant force? Most people clock on pretty quickly that it's this way with 150 newtons. So this is an example of a 1D forces question. There is one dimension of travel, left or right. There's no coming out the page, there's no going in, there's no going up, and there's no going down. That would be 3 dimensions. So what we're going to look at today is we're going to look at what happens in 2 dimensions. Now, to do this, it helps if you have graph paper, but most definitely you need a ruler. And it's all going to be about drawing and using a ruler for scale. So, a bit like drawing a treasure map this, we're going to start off, we're going to say here, 1 centimetre equals, let's keep it really simple, 10 newtons of force. And what we're going to do is we're going to look at the following problem. We're going to say here's an object and it has acting on it 30 newtons of force acting in this direction. So I draw 3 centimetres, 30 newtons. But in this one, it has 40 newtons of force. And the question is, which direction and what strength of force will that have? What will the resultant look like? So, how to do it? Really easy. Number 1, you finish the quadrilateral. Here we go. Lateral. I think I've spelled that wrong. Quadrilateral, there we go. I don't know. I know that's the right word because I'm doing it with my 7-year-old at the moment. He's doing the name of shapes. So, what do I mean? All I mean is I just turn it into a rectangle, like so. I draw some little arrows to show it's heading this way. Next, number 2, I join start to finish. I'm going to use a different colour for that. I'm going to use blue. So all I do is I go from the object and I go across to the corner. That is my force. Now you might have known I was a bit cheeky here. I can't possibly have worked this out because I haven't got a ruler and it's changing shape. But this is a 3, 4, 5 Pythagorean triangle. So I cheated. I knew what the answer was going to be on this one. But you don't necessarily always have to. So all you do is you put your ruler on it, measure it, use your scale, read your scale off and put your answer in. If you want to be mega sure, you can use Pythagoras, but you don't have to for this. So that is measuring forces with a vector. Have a go at 2 more. I'll write them down. So number 2, do one going this way with 40 and this one going this way with 60. Try that, work out the missing bit, which way is it going to go. And number 3, try it going this way. We'll go 70 and up this way 20. So have a little practice with them. The more you practice, the easier these get. So that's the first part. If you can do that, this question usually brings with it about 3-4 marks. You've already got 2. The other part is called the bearing. Now, if you've done D of E or any sort of map reading exercise, you know that a bearing is relative to north. So if we take north there. Now, if you remember from your saying, it's never eat shredded. The shredded wheat company must have hated this. Shredded wheat. Okay, so we start with north and we call north 0 degrees. And obviously 90 degrees, 180 and 270. We're going to use those. However, the way we write it is like this. 0, 0, 0. Because once we go all the way round, we've got to 3, 5, 9. So 90 would be written 0, 90. 45 degrees would be written 0, 4, 5. So if I was to take my example again, what I want to do is measure this angle here and say it was 50 degrees. I'd write 0, 5, 0 degrees, like so. So that's bearings, pretty easy. Last bit of this lesson, quite a short one. Balancing forces, checking on them. Do these forces balance? So I've got two forces acting here at an angle, and I've got this force here trying to balance it out. And I want to find out, very simply, I don't want to get into the mathematics of it and measuring it all. I just need to know, do they balance out? So here's the check. If all three arrows can form a triangle, they balance. Now I can cheat. I can grab this. So if I grab this line here, if I can take this line, I know it keeps getting bigger and smaller, and I can put the tail and the tip like that. If they touch and form a triangle, they balance. If they don't, so if I go back again and I grab it, if one arrow was too big, for example, like that, and I put it there, and we have leftovers, or it was too small, then we don't have balanced forces. Now I don't think 2 years of exams, I've never seen them ask that, but it could be a quick 1-mark sentence. How can you check 3 forces are balanced? And the answer is you form a triangle. And that concludes this lesson. Any problems? Comments in the comment box. Take photos of your work, post them online, just press handed in. Keeps me happy, means I can tick a box and said that you're doing your work. Any problems, let me know. Take care. Bye.